Hi, ladies and gentlemen. This is a bulletin letting you know we're having a magnetosphere reversal. One of the instruments picked up a reversal, and since that time, all of the instruments have stopped reporting data. The data may be there right now as I'm recording this, and that's always a danger. It takes an hour or two production time, an hour or two upload time, and stuff happens during that time, like earthquakes and further reversals, stuff like that. But, here's these nice, consistent proton waves, and they're consistent with waves of helium that we've seen in past, and we've showed you time and time again. We notice a brightening in the sun. We looked at it closer. We know there's a sunspot turning in on the left, but it was the brightening on the right that caught our attention, and at the top. Here is that instrument where we used to track waves and waves and waves of helium, that middle dark count. The reason they call it dark count is because it's not ionized. The warning line used to be about 42, and I'm not sure what units they use because they never have ever put a legend on this graph. The thing I liked about it before they started smoothing out the data, I'm glad they went ahead and put a line where the count is. Just a few days ago, this count was below 40. So the fact that it's up there at 46, 47 means we're getting hit by waves of helium. Now, I don't think they're coming from coronal hole streams, but there are some, let's say, weak areas in the middle of the sun that could be letting out some coronal holes. However, the speed does not dictate that we're seeing coronal holes, but we think we know why. This instrument also gives you a key wavelength of X-rays that we always have been warning you about for the last 3 months. It's the background X-rays from 1 to 7 nanometers, and that's that purple line. That purple line also spikes when we have a flare, and it's almost simultaneous with the flare because the flare travels, those X-rays are traveling at the speed of light. So they get here in about 9 minutes after a solar flare. The units being measured is very misleading. The units being measured in here it's 0.1 to 7 nanometer range, but the units being measured are in milliwatts. Well, I mean, most irradiance is reported in watts per meter squared. Now, come on. Why does somebody got to go to milliwatts? Oh, and then it can't be per meter squared. It has to be meters to the -2. Well, that's a centimeter. So they can't even tell you it's a centimeter. And when you factor in what it is and what this means in watts per meter squared, you're getting up to 1,000,000 watts per meter squared for every 0.1 increase in this value. It's simple math, and it's simple conversion. You convert milliwatts to watts by multiplying by 1,000. Well, so there, your numerical value just went up by 1,000. And you got to look up how many square centimeters are in a square meter. Well, what's 100 times 100? So that's a big difference when they convert a common measurement for irradiance into something more confusing, that's for sure. And this is what I mean about the solar wind. This instrument, the solar wind hasn't been above 400 kilometers a second, and I don't know how long. And you guys that follow this know this. And we're seeing very consistent temperatures, very consistent speed, and little fluxes in density. And what's ironic is we remember the times when the coronal hole streams were going 1,000 kilometers a second. 900 kilometers a second. There was a period where they describe the wind as slowing down to 600 kilometers a second. Well, if that's slowing down, what the heck is this 300, 350, 400, maybe a 450 when you blink an eye? So we know what's going on, and we figured it all out. And that's what this video is about, is kind of explaining these dark areas and gray areas that you guys are seeing on the instruments and that nobody's explaining to you. Not on YouTube, not in science, not in your astronomy meetings, nothing like that. First of all, if there's a brown dwarf, and it's really a fragment, if this fragment spinning very, very rapidly makes a complete loop around the sun, those black arrows indicate the gravitational focusing of those neutral helium. And even ionized stuff gets drawn in via the sun's magnetic field. Not on the same vectors, but pretty much get drawn into the sun. And they spiral in. But as this thing makes a really fast loop around the sun, imagine it being leaving a smoke screen, like a battleship, or something intentionally making a smoke curtain. As you leave a loop, the gravitational focusing then is more of a disk, and the inward motion and the outward motion begin to oppose each other. Why? Because this thing has made a complete loop, and the sun, that which it's not drawing completely in, is focusing. And just like when a comet passes the sun and slings by, this now, for all the streaming in particles, there are also particles that are streaming in and stream past the sun. And those that stream past the sun generally are ionized and accelerated to about 450 kilometers a second. How do I know? Because I've showed you about 20 articles about that. So then when you have ingoing wind, that's been, because this thing is shooting CMEs constantly. It's spinning so rapidly, it's so highly magnetic, it's popping flares constantly. And the magnetic field is so strong that even the sun's wind from far, far away will still create auroras. But you have it being now focused in, not from one general direction as when it was further away and seemed like it was camped out in Aquarius for 2.5, 3 years. Now this thing has picked up so much speed, it itself is traveling about 400 to 450 kilometers a second. And here it is. Here it is. You got opposing winds now. And now the sun's wind, remember, are spiral. This does not depict any of the sun's wind. This is simply new CMEs resisting old CMEs, because they have shot CMEs in all directions. You have all this chaos, and it's represented in the jagged nature of the signatures. Anytime you see a jagged signature on a solar or cosmic ray signature, or even X-ray signatures, and even radio wave signatures, you get the extreme fluxing due to one thing: turbulence. So then what's been happening is that we're getting particles, and the particles are represented as protons on some of the instruments that use the plastic impact panels, because a helium ion will be counted as a proton, because it's still a single nucleus with no electrons. And And when you look at the densities gradually falling, you would say, well, how in the world are we now having a magnetosphere reversal? How is that possible? What the heck is going on? Well, we know electrons are very and highly magnetic. Interplanetary magnetic fields. When you hear that term, interplanetary magnetic field, that's an electron-based field. That's what creates the magnetic field. And so we look on this electron simulation. We screen captured where the tail stream disappears completely in our magnetosphere. The sun is off to the right. There's supposed to be a tail stream or a crescent-shaped tail stream where the sun's wind is going from right to left. Now fluxing in, and if you guys go back and look at these instruments, you'll see that many of these fluxes come in pairs. Pairs of groups of electrons coming in pairs. First one and then the other right after it. Two pulses of electrons. What travels in pairs? In the universe, helium-3 and helium-4. Together, they travel together. They're never, hardly ever separate from one another. They're married to each other, not just in our solar system, not just in our galaxy, but in the entire universe. And so we captured this magnetic reversal, and I can't really call it a compression, because the bottom line, the bottom axis on this graph, 0, you see 0, 5, 0, minus 5, those are Earth radii, and the magnetic field is out there at 10 Earth radii in either direction. So 10 Earth radii isn't really that abnormal of a compression. So what we have is a complete sudden fluxing of our magnetic field. Enough so to change it. And if we were able to get data on the other simulations, the vectors will show a reversal or a stalling, complete stalling of the interplanetary magnetic field, which creates that tail stream, by the way. But we have electrons, but we're not having saturations. And sometimes we have saturations and we still don't get this reversal. So there's a reversal happening. What's causing that reversal is not an object that's opposite the Earth, unless it's Jupiter, and Jupiter is opposite the Earth. So now we're factoring what the heck would create this anomaly, and Jupiter would only enhance the wind. It's pulling on the wind coming from the sun because it's blowing by Earth and headed in the direction of Jupiter. You know, the giant suction cup in the sky. And so Jupiter wouldn't be doing this to our magnetosphere, is what I'm trying to say. So what's happening on the sun right now is there's no coronal holes, period. There's hardly any particles coming from the sun. All that we're getting from the sun would be focused particles from the brown dwarf, and some of the sun's stuff mixed in there. But you know, the sun's always putting out something. But the coronal hole streams, the concentrated high-speed particles, that's what it's lacking. And with good orientation at the sun's north and south pole, finally, we have good, strong magnetic signatures at north and south in terms of polarity. So to wrap this all up,